Hi everyone, in this video I want to talk about operations with vectors, and I'm going to include a little bit of information about graphs um, of vectors as well, because I have seen those in relation to vectors on the ACT before. So here are the two problems that we'll do, and to make sure we don't take ourselves too seriously, let's think about the fun question. What is a family tradition you look forward to each year? On the math section, every so often you see a question about vectors. And I nested this under geometry. Honestly, it could be under algebra as well. Sometimes it's taught usually in a pre-calculus class or an algebra class. Occasionally you could even have it right after trigonometry. Depends on how your school teaches it, but basically vectors go like this. You have what's called the geometric approach and the algebraic approach. So the geometric approach is like this. If you had, say, an arrow pointing downward, you could draw that arrow to indicate that you wanted to say that this is 50 miles per hour going south. Or you could draw an arrow going upwards about the same length, 50 miles per hour going north. You could do half of that going downwards. That would be 25 miles per hour going north, or sorry, south. So a vector it looks like an arrow, and you have a specific magnitude, also known as length, and direction. So it's got a certain size, like this small one was going, that's half of the size of this one. And it's going in a certain direction. So the place where you would see this would be wind patterns, water patterns in the ocean. Um, you study this in calculus quite a bit, but it's something that relates to algebra so much that an ACT test can test you on stuff like this, because you can see variables going on here, you can see operations. The operations really are not too hard, which is nice. But sometimes people see questions like this and they think it's super foreign. So I'm showing you that vectors really aren't too bad. This component form looks like an ordered pair, but it doesn't have parentheses. It has those like those arrows, those brackets. So think about this as component form, and then a lot of people debate about what to call the IJ form, but you could call this component vector form. I've also seen it as unit vector form, IJ form, linear combination form, lots of different names for the IJ. So if you were going to add two vectors, let's say I said this is vector u, notice the little arrow over there, that means vector, and this is vector v, what would u plus v be? And I recently saw a problem like this on there. So the way you do that is you go u plus, I'm drawing literally that same v coming it's like tip to tail is the way that you draw them, in order to figure out the u plus the v. So the u plus v vector is this bottom one and only the bottom one. The way you do it is you could draw both of them. The algebraic approach that I'm seeing up here is just they give you the numbers. So the vector 1, 5 is just, can you go 1, over 1 up 5, draw that 0.15, and then the vector is just going out to that point, starting at 0, 0 at the origin. So right here, all I'm doing, shortcut, is, if I drew both of those vectors and I added one to the other, all I would get after I did that is just add them straight down. So 1 plus -6 is -5, and 5 plus 2 is 7. So U plus G is just adding them together. Also, this 5 right here is called a scalar. You can multiply 5 times the 1 and the 5 to get 5 and 25. So it's like 5 times that equals this. So those would be our 2 answers for this problem. Component vector form operates very similarly, but this one's a little harder because it kind of throws a few different things at you at once. Mind you, this also could say minus, and you'd have to subtract, one from the other. Okay, so negative f tells me it's going to be negative 8i plus 10j, and then plus 3b would be 3 times the whole b. So I do have to distribute twice here. I have negative 8i minus 10j minus 36i minus 18j. And then I just combine like terms. So I would do my i's together and my j's together. So I'd have negative 44i and then minus 28j as my final answer. Note too that is the same thing as in component form, just negative 44 comma negative 28. If you had to, I don't know, graph something or convert from one to the other, draw, pick a graph that matches a certain situation. I wanted to show some of the geometric component and as well as the algebraic. So try 2 practice problems, and one is in the component form. This is subtraction. Watch out for the minus, for both parts. And then this is, we have scalars and subtraction and a negative, 7 involved. So try those. You can pause the video and check your answers in a second. Okay, the answers are here. We've got 9 and 4, and then negative 55i plus 9j. So I hope this video helped you in some way. And I want to leave you with a John Lennon quote. Life is what happens when you are busy making other plans. I love this because it really makes me think. And hopefully you are planning to do well on an ACT, and hopefully that's what happened. But who knows? Life sometimes throws curveballs at you, and you have to figure out what's going to happen. Maybe even sometimes during a math problem, such as vectors. So feel free to subscribe if you'd like to keep up with new videos, and you can leave an answer to the fun question in the comments. I hope you have a great day.